Hello students, today we are going to learn rational exponents of real number. Okay, so first one is principal nth root of positive real number. Okay, so suppose a is a positive real number and n is a positive integer. Then a raised to 1 by n is called principal nth root of positive number or principal nth root of a. Okay, so a raised to 1 by n, that is the principal nth root of a, or we can write in this way, nth root of a. Okay, so this sign is called as radical sign. Okay, this is called principal nth root of positive number a. Okay, or we can write nth root of a, and this sign is called as a radical sign. Okay, so definition we can write a is a positive real number, n is a positive integer such that x raised to n is equal to a. Meaning of this means x is equal to a raised to 1 by n. Okay, so there is a positive number x such that x raised to n is equal to a. Okay, so a raised to 1 by n, that is a principal nth root of a or nth root of a. We can denote like this way, either this in exponent or in radical sign we have to denote like this way, nth root of a. Okay, understand this one. So if n is equal to 2, then that is a raised to 1 by 2, or we can write square root of a. Okay, or we simply say that it is a root of a. Okay, if n is equal to 3, that is a raised to 1 by 3, or we can write like this way. This is called as a cube root of a. Okay, this is square root of a, this is cube root of a. Okay, so this is the principal nth root of a positive real number. If a is positive real number, n is positive integer, then a raised to 1 by n, that is a principal nth root of positive number a. Okay, or we can write like this way. This sign is called as a radical sign, and if n is equal to 2, we can write a raised to 1 by 2 or root a. If n is equal to 3, a raised to 1 by 3, we can write like this way, cube root of a. If suppose example is this 8 upon 27 raised to 1 by 3, and if you have to simplify this 8 upon 27 raised to 1 by 3, so here when we simplify this is equal to a positive real number. Okay, x. So if positive real number x is equal to this, x raised to 3 or x cube is equal to 8 by 27, mean x, value of x is cube root of this number. So 8, that is a cube of 2, and 27 is, that is a cube of 3. So value of x is 2 by 3. Okay, so 8 by 27 is 1 by 3 is equal to 2 by 3. Okay, so understand this one. Now we will see principal nth root of negative real number. Okay, second point is principal nth root of negative real number. Okay, means here if a is negative number, okay, there are again two types, means when n is odd and when n is even. Okay, so first I am considering n is odd number. Okay, so if n is odd number and a is negative real number, okay, means it is like this way, minus a raised to 1 by n. Okay, a is negative, means here this is negative number and n is the odd number. So in that case we have to find nth root of this. It is equal to minus of mod of a raised to 1 by n. Okay, means we have to find nth root of a and give minus sign. Okay, find nth root of a and give minus sign to it. That is a principal nth root of negative real number when n is odd number. Okay, when suppose here I am taking example minus 8 raised to 1 by 3. Okay, so I am giving minus sign outside this. Okay, find the cube root of 8. Okay, so cube root of 8 is 2, so it is a minus 2. Okay, find first cube root of only number and then give minus sign. Okay, when n is odd. Okay, but when n is even and a is negative real number or negative number, we can say when n is even and a is negative real number, then minus a raised to 1 by n, this is meaningless. Okay, if n is even and a is negative real number, then minus a raised to 1 by n is meaningless. Okay, suppose here minus 9 raised to 1 by 2. Okay, so minus 9 raised to 1 by 2, this is not possible. Okay, there is no any number whose square is a minus 9. Okay, understand this. Therefore when n is an even number and a is negative real number, so minus a raised to 1 by n, this quantity is meaningless. Okay, but when n is odd number and a is negative real number, then we can find nth root of that number by using this method. Okay, give minus sign and find the nth root of that number. Okay, so that is the answer of nth root of negative number when n is odd. Okay, but when n is even and a is negative real number, that quantity is meaningless. Okay, understand this one. So similarly, when exponent is a rational number, means in p by q form, suppose exponent that is equal to in p by q form, and we have to define this a raised to p by q. So a raised to p by q, how we find this? That is a raised to p raised to 1 by q. Okay, so we have to find the qth root of a raised to p. Okay, suppose 4 raised to 3 by 2. Okay, so if we take 4 raised to 3 by 2, then how we solve this? 4 raised to 3 by 2, that is a 4 raised to 3 raised to 1 by 2. So 4 raised to 3 is 64 and raised to 1 by 2. So 64 raised to 1 by 2, that is a square root of 64. So it is a 8. Okay, so a raised to p by q is there. We can write a raised to p raised to 1 by q. Okay, so suppose 4 raised to 3 by 2 is there. 4 raised to 3 raised to 1 by 2. Okay, so this 4 raised to 3 by 2 means 3 by 2 we can write 3 into 1 by 2. Okay, so a raised to mn, we can write a raised to m raised to l. Okay, so 4 raised to 3 raised to 1 by 2. So 4 raised to 3 is 64 raised to 1 by 2. So 64 raised to 1 by 2 means square root of 64. So that is a 8. Okay, understand this. Now we will write all the laws of exponents together and then we will solve examples. Write laws of exponents. So that is the first one is a raised to m multiply by a raised to n. That is the first law, a raised to m plus n. Then second law is a raised to m divided by a raised to n is equal to a raised to m minus n. Okay. Then third law is a raised to n multiplied by b raised to n is equal to ab raised to n. Okay. Then a raised to n divided by b raised to n is equal to a by b raised to n. Then fifth one is a raised to p by q, or m by m we can write a raised to m by m. We can write a raised to m raised to 1 by m. Okay. Then sixth one is a raised to m raised to n, that is a raised to mn. Okay. And what is remain? A raised to 0, that is any number raised to 0 is 1. Okay. So a raised to m into a raised to n, a raised to m plus n, a raised to m divided by a raised to n, a raised to m minus n, a raised to n into b raised to n, a b raised to n, a raised to n upon b raised to n, a by b raised to n, a raised to m by n, a raised to m raised to 1 by n, a raised to m raised to n, that is a raised to mn, and a raised to 0 is a 1. Okay. And one more is remain, that is a raised to minus n is equal to 1 by a raised to n. Okay. So these are the laws of exponents. We have to use this and we have to solve examples based on this. First example is simplify each of the following. Okay. So in that first one it's 7 raised to n plus 2 minus 3 into 7 raised to n plus 1 upon 20 multiplied by 7 raised to n minus 2 multiplied by 7 raised to n. Okay. So first step is 7 raised to n plus 2. This we can write 7 raised to n multiplied by 7 raised to 2 minus, okay, we have to use here first law, a raised to m into a raised to n, a raised to m plus n. So here already a raised to m plus n given. We are writing in the form a raised to m into a raised to n minus 3 into 7 raised to n plus 1. We can write 7 raised to n multiplied by 7 raised to 1, or we can write only 7 divided by, from this we can take 7 raised to n common. Okay. So what is remain? 20 minus 2. Okay. Now again from this term and this term we can take 7 raised to n common. So from numerator 7 raised to n we can take common. What is remain? 7 square minus 3 into 7. Okay. And denominator 7 raised to n, 20 minus 2, that is a 18. Okay. This 7 raised to n will get cancelled. Okay. So what is remain? 7 square 49 minus 3 into 7, that is a 21 divided by 18. So 49 minus 21, that is a 9 minus 1 8, 4 minus 2 2, 28 by 18. If we reduce this, 14 by 9. Okay. So answer of this is 14 by 9. Okay. Everywhere we are using laws of exponents. Okay. First a raised to m into a raised to n, a raised to n plus n. We have to use this law here also. Okay. Then 7 raised to n upon 7 raised to n, we use directly law, that is a 7 raised to n upon 7 raised to n, 7 raised to n minus n. So 7 raised to n minus n is n minus n is 0, 7 raised to 0. So 7 raised to 0 is 1. Okay. So after simplifying we will get answer is 14 by 9. Okay. Then we will take second question. Okay. Another two examples are there. I will give for practice. Okay. So solve that examples as a practice. Okay. Now I will take second question. Okay. Second example is if 9 raised to n multiplied by 3 square multiplied by 3 raised to n minus 27 raised to n divided by 3 raised to 3m multiplied by 2 raised to 3 is equal to 1 by 27. Then we have to prove that m minus n is equal to 1. Okay, so I'm taking this one, 9 raised to n. Now see here, 9 we can write 3 raised to 2. Okay, so I'm writing 9 raised to n, that is a 3 square. 9 we can write 3 square and raised to n into 3 square into 3 raised to n, that as it is, minus 27 we can write 3 raised to 3 raised to n divided by this 3 raised to 3m into 2 raised to 3 as it is equal to 1 by 27, that is a 1 upon 3 raised to 3. Okay, now here base of all this number is 3, so we can add exponent. So what is remain? 3 raised to 2n, this 2 into n, that is a 3 raised to 2n. So 3 raised to 2n, then here 3 square and here 3 raised to n. So 3 raised to 2n plus 2 plus n minus 3 raised to 3 raised to n. So a raised to m raised to n, that is a raised to mn. So it is a 3 raised to 3m divided by 3 raised to 3m multiplied by 2 raised to 3 is equal to 1 upon 3 raised to 3. Okay, next step. Now here 3 raised to 2n plus n, 3n. Okay, so 3 raised to 3n plus 2 minus 3 raised to 3n divided by 3 raised to 3n into 2 raised to 3 is equal to 1 upon 3 raised to 3. Okay, now 3 raised to 3n plus 2 we can write 3 raised to 3n into 3 square minus 3 raised to 3n divided by this as it is into 2 raised to 3 is equal to 1 upon 3 raised to 3. Now from these two terms, this is the first term, this is the second term. So from these two terms we can take 3 raised to 3n common. So what is remain? 3 square minus 1 divided by 3 raised to 3m and into 2 raised to 3. Okay, is equal to 1 upon 3 raised to 3. Now 3 raised to 3n as it is 3 square minus 1, that is a 3 square is 9, 9 minus 1 is 8 divided by 3 raised to 3m, 2 cube is 8 is equal to 1 upon 3 raised to 3. So this will get cancelled. Okay, what is remain? 3 raised to 3n upon 3 raised to 3m is equal to 1 upon 3 raised to 3. So here we can use this a raised to n divided by a raised or a raised to m divided by a raised to n, a raised to m minus n. So 3 raised to 3n minus 3m is equal to 1 upon a raised to n is equal to a raised to minus n we can write. So it is equal to 3 raised to minus 3. Okay, now base is same, we can compare exponent or equate exponent. So here 3n minus 3m is equal to minus 3. Okay, if we divide it by 3 to each term we will get n minus m is equal to minus 1. Now we have to prove that m minus n is equal to 1. So take minus n common from this. So minus m minus n is equal to minus 1. If you multiply by minus 1 both sides, you will get m minus n is equal to 1. Okay, understand this. Now we will take next example. The next example is assuming that x is a positive real number and a, b, c are rational numbers. Show that x raised to b divided by x raised to c raised to a multiplied by x raised to c upon x raised to a bracket raised to b multiplied by x raised to a divided by x raised to b bracket raised to c is equal to 1. Okay, Now I am taking LHS. Okay, so this is x raised to b upon x raised to c. We can write x raised to b minus c raised to a, multiply by x raised to c divided by x raised to a. We can write x raised to c minus a raised to b, and x raised to a divided by x raised to b, we can write x raised to a minus b raised to c. Okay, now a raised to m raised to n, a raised to mn. So this a multiplied to this b minus c, so x raised to a multiplied to b minus c. Then x raised to c minus a raised to b, so b multiplied to c minus a, and here c multiplied to a minus b. Okay, so x raised to ab minus ac, then x raised to bc minus ab, and x raised to ca minus bc. Okay, now we are basic same, so we can add this exponent. So ab minus ac plus bc minus ab plus ca minus bc. Okay, so here plus bc minus bc will get cancelled, minus ab plus ab, and minus ac plus ca or ac. So answer we will get x raised to 0, that is a 1. Any number raised to 0 is a 1, and x is a positive real number. Okay, so here x raised to 0 is a 1. Okay, which is equal to RHS. Understand this? Now we will take next type of example. Next example is show that 1 upon 1 plus x raised to b minus a plus x raised to c minus a plus 1 upon 1 plus x raised to a minus b plus x raised to c minus b plus 1 upon 1 plus x raised to b minus c plus x raised to a minus c is equal to 1. Okay, now I am taking LHS, that is the 1 divided by 1 plus. Now x raised to b minus a, we can write x raised to b divided by x raised to a by using this law. A raised to m minus n, we can write a raised to m divided by a raised to n. Okay, so x raised to b minus a, we can write x raised to b upon x raised to a plus x raised to c minus a, x raised to c divided by x raised to a. Similarly for all this, 1 divided by 1 plus this, we can write x raised to a divided by x raised to b plus x raised to c divided by x raised to b plus 1 divided by 1 plus x raised to b upon x raised to c, x raised to a upon x raised to c. Okay, so 1 divided by, now here we can make same denominator, so here multiply by x raised to a, so we will get x raised to a plus x raised to b plus x raised to c divided by x raised to a plus, here we have to multiply by x raised to b, so 1 divided by x raised to b plus x raised to a plus x raised to c divided by x raised to b. Here multiply by x raised to c, so 1 divided by x raised to c, x raised to b plus x raised to a divided by x raised to c. Okay, so 1 divided by this fraction means this is reciprocal. Okay, so x raised to a divided by x raised to a plus x raised to b plus x raised to c plus again same x raised to b divided by, now I am writing x raised to a first, then x raised to b, then x raised to c. Okay, we can change the order because addition is there, so addition is commutative, so we can change the order. Then 1 divided by, if we reciprocal this, x raised to c, then what is remain, x raised to a first I am writing, then x raised to b plus x raised to c. Now you can observe here denominator is same, so denominator we can write x raised to a plus x raised to b plus x raised to c, and in numerator x raised to a plus x raised to b plus x raised to c is there, so both will get cancelled. Answer is 1. Okay, understand this. So for more practice, solve examples in given worksheet. Okay, and after that we will take next video we will take more examples. Okay, for of another type. Okay.